Introduction. A virtual mouse is an advanced software-based input device that simulates the function of physical mouse. It allows users to control their computer cursor without requiring traditional hardware. Key features of a virtual mouse: camera-based control, gesture recognition, voice command integration, touchless interaction. Literature survey. Tools and documentations. OpenCV documentation, MediaPipe, TensorFlow for gesture recognitions. Books. Computer Vision Algorithm and Application by Richard Skersky, Gesture-Based Communication in Human-Computer Interaction by Anthony Conway, Problem Statement. Traditional computer mouse systems have limitations in terms of mobility, accessibility, and usability. People with disabilities, injuries, or mobility issues often face difficulty using conventional mouse devices. Specific standards are limited mobility and accessibility, inconvenient for presentation or interactive applications, space constraints. Proposed system to design a virtual mouse which detects the hand gestures and perform mouse operations only using the fingers. We use different combinations of fingers to perform various operations of the mouse according to the which particular combinations of finger is recognized. In proposed system, user don't have to color the fingers with specific colors are not required to use any device or sensors. Here, here is an illustration of hand gestures. The thumb finger and the point finger are meeting joined together to control the speaker. This is the one of the applications for gesture controls. Methodology steps. It detects the camera video interface will be start. The camera can extract and recognize human and hand gestures from video interface. Hand tracking functionality is done by MediaPipe. After recognition, cursor move according to the various operations. Here is the step one hand. The gesture is done in the hand part. The web camera captures the actions. The hand gesture recognition controls the parts and control mouse operations are done and cursor is moved according to the operations. Classification of models. Import libraries initialize MediaPipe hand detections, capture webcam feed, process frames, detect gestures, control mouse movements. We can interlink with both methodology and classification of models. Both steps involve the same process. Implementation. Real-time video capture OpenCV. Use OpenCV to video capture for function to capture video frames from webcam, process each frame to detect and track the user hand detection and tracking with MediaPipe. Utilize MediaPipe hand model to identify hand landmarks in video frames, extract the key hand landmarks such as fingertips and base of the hand. Gesture recognitions. Analyze the position of the landmark, interpret gestures, cursor movement, map the coordinate of the index finger to the screen using scaling factor. Left click details the pincher to gesture, thumb and index finger for touching. Here is the illustration of that. Implementation mouse control PU auto GUI. Using PY auto GUI a function to perform mouse action based on recognized gestures. PU auto GUI move to X to Y to move to cursor. PU auto GUI click for click gestures. PU auto GUI for scrolling gestures to the follow. Integration and optimization. Continuous process frame in loop for real-time performance, applying smooth techniques to reduce jitter for cursor movements, optimize the code to ensure the low latency and different hardware setups. Here are the minimum requirement resources for to run this program. Paragraph need. Paragraph needed i3 or above, RAM 8 GB or above, webcam 720 HD webcam, resolution 122 108. Operation systems of Windows XP, 7 or high Windows OS. Ideal on VS Code. Programming languages or Python packages in Python. Future scope. Advanced gesture recognition supports more complex gestures. Pitch to zoom, swipe actions. Cross-flat support. Compatible with more devices like smartphones, smart TVs and gaming consoles. Voice control. Integration with voice assistants for hand-free control. Multi-device control. Control multi-device with one mobile device. AR/VR integration using virtual and augmented reality environments. Haptic feedback. Provide physical feedback for better interaction. Accessibility. Features for people with disabilities like eye tracking and head movements. Low latency and high fidelity. Improve response time and accuracy, especially for gaming and design.